Hi everyone, we're going to find information about the square root function. We're going to graph it, table of values, and so forth. On these two, we're going to see where y is positive, where it's negative, and on these two, we're going to talk more about end behavior. So this would be your end behavior of the function. All right, and symmetry, I'm going to discuss these two together. They're kind of, I wish I had put those together. Okay, so anyway, these two kind of go together. All right, so here we get started. The first thing we're going to do is do a table of values. Now, when we do a table of values for this, we already should know that the domain is x has to be greater than or equal to 0. Because you can't put negative in here if we're talking about the real numbers. And that's what we're talking about on this. So we're going to start with 0. And then what I'm going to pick for my values are ones I can take square roots. Because I'm just picking a table where I can easily graph this. So I can take the square root of 0, which is 0. Square root of 1 is 1. I don't want the square root of 2 because it's 1 point something. I'm going to go ahead and do 4. Square root of 4 is 2. And the square root of 9 is 3. And then I'm going to go ahead and graph it. Now all this information I'm going to put basically on this next page. So you want to probably have this written down. All right, so here we go. I went ahead and graphed it from the table and then filled in and made it continuous function. Okay, so basically y, it says where is y positive in what interval. So y is positive, and you're talking about the x between 0 and infinity. You're looking at the x values when they're asking what interval is it positive. All right, and you can't equal 0 because 0 is not positive. Okay, it's not negative, so we can say that's not applicable. And it's increasing, so f of x approaches infinity, so this y portion gets bigger and bigger as x gets larger and larger. All right? It's not decreasing in either function, so we're only looking actually at one end behavior. When you're looking at end behavior, you're looking at this. So you're looking at what's happening with this arrow part, okay? The symmetry, there's no symmetry here. So it's not symmetric to the origin nor to the y-axis because it's only in quadrant 1 here. So this function's not even, it's not odd, it's neither. So I'll just put neither here because you have to answer that. Neither. So it's neither even or odd. And is this function 1-to-1? Yes, it is. If you do a horizontal line test here, it might not look like it is, but it's not. It is 1-to-1. So we can do the inverse. So I'm going to go ahead and write the values here. We had 0, 1, 4, and 9, which is 0, yeah, 0, 1, 2, and 3. So that's your f, and f inverse is where you switch the x and the y. So it's 0, 0, 1, 1, 2, 4, and 3, 9. And you notice, so I'm going to go ahead and graph the inverse. So 0, 2 goes to 4, 3 goes to 9. You notice this is really y equals x squared, but where x is greater than or equal to 0 with our restrictions. So y equals x squared and y equals the square root of x are inverses of each other when you have this restriction. Okay, so when I graph the inverse, or this was the inverse, so let me graph the original. And we go to 4, goes to 2, 4, 5, 6, 7, 8, 9. Hopefully that's it. So basically, this is your square root function. And you notice it reflects over the y equals x. Okay. Now, next thing we're going to do is do transformations on it. And the general form would be y equals square root of x minus h plus k. And again, I'm just going to go ahead and shift this. Let's just shift it to the right by 2. Here's your parent function. 4 goes to 2, and 9. 4, 5, 6, 7, 8, 9 goes to 3. So something like that. Okay, so what I'm going to do is just shift this to the right by 2. Instead of doing a table of values, I'm just going to shift these points over by 2. I'm going to shift that over by 2, this over by 2, this over by 2, and this over by 2. So I just shifted the whole thing. It should keep going up here, over by 2. That's a horizontal shift to the right by 2. Now to do the vertical shift, I'm just going to do y equals square root of x plus 2. So that means I'm going to take my parent function and which is here, and just go up by 2. So I'm going to go up by 2 here, up by 2 here, up by 2 here, and up by 2 here. And that's just a shift up by 2. Okay? And that's all of this one. And thank you, and I hope you all have a great day. Bye-bye.